let's start with this two-phase method. Right, so two-phase method, the name itself suggests that there are two phases in this method. So so LP problem is solved in two phases. Right, so what happens in phase 1 and what happens in phase 2 is different. Right, so phase 1, what we are going to do is that in this phase we find initial basic feasible solution. So initial basic feasible solution test karunga initial feasible solution to the original problem and for this artificial variables are considered, right? So artificial variables are considered and driven to zero, right? So the same strategy, we have to neglect or we have to remove this artificial variable from our basic the optimal solution. So driven to zero. So this is our strategy that we have seen in our I guess you understood that strategy in your big M method as well as this normal simplex method. So now what different that we are going to do is that our original objective function will be there, but here a new artificial objective function, that is W is created. This new artificial objective function is then minimized, right? So irrespective of the given original objective function is maximization or minimization, this new artificial function is always to be minimized only, right? And at the end of the phase 1, there will be 3 cases that may generate, and today we are going to see only case 1, right? So I will be writing only about the case 1, that is if the minimum value of objective function and what is that our function W is greater than 0, that is W is greater than 0 and at least one artificial variable appear in the basic variables, then the given problem has no feasible solution and the process can stop, and the process will stop. So now this is the criteria. There can be other 2 cases that may generate, and that will be seeing afterwards. But here there is that we are going to see only case 1 today, in which what will happen is that the objective function where your W will be greater than 0, and that particularly signifies that this is the type of a numerical in which there is no feasible solution, right? You cannot find any feasible solution, and if it is case, you can stop this particular process, right? So we are going to see only one short numerical of this case here today, and I'll be making you understand what we are going to do. Right now, this is related to the phase 1, and we are going to see the case 1. But what about the phase 2? right? So phase 2 also we have to take into consideration. So what happens in phase 2 is, in phase 2, the feasible solution that is obtained, so in phase 2, in phase 2, the basic feasible solution obtained at the end of phase 1, at the end of phase 1, is used as a starting solution, for the original problem, right? So the meaning of that, I'll be making you convey in our next lecture, right? So what will happen in today's lecture is that we are going to start with a numerical, but what will happen is that we'll be coming across the case 1 in phase 1, where there is no feasible solution to that particular problem. So if there is no feasible solution, we do not need to go to the phase 2, and phase 2 will remain unattended, right? So there is no need actually to go to phase 2, right? So the use of this phase 2 actually we are going to see in our next no the next lecture. So I'll be making you understand this phase 2 at that particular point, because today if I make you understand the phase 2, chances are there that you may not recall that properly when we are going to actually solve the numerical, right? So particularly let's start here the problem itself, and let's see how much you understand about this problem. So because the problem is very easy, I think that you'll be understanding, because as of now today there won't be any confusion, because we are not going to go for phase 2. But when we go for phase 2, some extra particularly what we can say attention or carefulness will be required at that stage. So let's start with a very simple numerical question. We have is that use two-phase method to maximize z is equal to 5x1 plus 3x2 subject to the constants which are given. Twice of x1 plus x2 is less than or equal to 1. We have another constant x1 plus 4x2 is greater than or equal to 6, and we have x1 x2 greater than or equal to 0, right? So now what we are going to do is that we don't need the original objective function as of now. So what comment we can write is that keep aside the original objective function, right? Considering constraints directly, so what are the constraints that we have? Twice x1 plus x2 greater than or equal to 1. So we have to remove this inequality sign. So what we'll have to do? Twice of x1 plus x2. Now this is less than or equal to. So less than or equal to matlab we will have to consider only slack variable, and slack variable will be positive. So plus s1 is equal to 1. Similarly, in constraint 2, we have to remove the inequality, but now here the sign is greater than or equal to. So here it will be x1 plus 4x2 minus s2 plus a1 is equal to how much? It is equal to 6. And what we can write is x1, x2, s1, s2 and a1 is greater than or equal to 0. So this is the case. Now as we know, we are going to start with our phase 1. So in phase 1, what we'll have to do is that we are going to consider the new objective function, right? So phase 1, we are going to consider new artificial objective function. And how we are going to write this? It is very easy. So we have already seen in phase 1, we have to always consider a minimization approach. So here we are going to write minimize. Instead of z, it will be w. and all other coefficients except for your artificial variable should be 0, right? So for all other variables, the coefficient will be 0, and only for artificial variable the coefficient will be 1, right? So you can write it as at 0x1 plus 0x2 plus 0s1 plus 0s2 plus a1. So this is how the artificial variable, artificial objective function is to be written, right? All the coefficients of all the variables will be 0 except your artificial variable. The artificial variable will have a 1 as a coefficient. And again, the constants remain same as that we have written earlier, that is subject to, it is twice of x1 plus x2 plus s1 is equal to 1. It is x1 plus 4x2 minus s2 plus a1 is equal to 6. And we have x1 comma x2 comma s1 comma s2 comma a1 greater than or equal to 0. All your constraints will remain same only. Only the objective function in phase 1 will be of a minimization type, and I've already told you how the objective function will be framed. That is, all the coefficients except for your artificial variable should be 0, right? So let's draw the table and now fill this constraints in our table. Just a minute. Right, so we have CB, we have CJ, basic variables, we have x1, x2, s1, s2, a1, and solution here, right? So we have x1, x2, s1, s2, a1, and solution that I have written. So according to the artificial objective function, it is 0, 0, 0, 0. Oh, sorry, it is 1 here, right? That 1 I'm going to write, right? So now in your first constraint, we had slack variable and not artificial variable. So slack variable will be given the preference. And in second constraint, we have both slack variable and artificial variable. So artificial variable will be given a preference, right? I think you are with me, right? So everyone is understanding. So here for it will be 0 and here it will be 1. And so I'm just writing it my constraints in the format of table. So it will be 2, 1, 1, 0, 0, 1. Here it will be 1, 4. It will be 0, minus 1, 1, right? And the this thing is 6. Now what we have to find out? We have to find out Zj, and we have to find out Cj minus Zj. So it will be here, Zj will be 1, it will be 4, it will be 0, it will be minus 1, 1, and here it will be 6, right? Because S1 terminology is 0, the coefficient of S1 is 0. So your Zj values will be right this. Cj minus Zj will be now 0 minus 1 is minus 1, here it will be minus 4, 0, here it will be 1, and it will be 1 minus 1, that is equal to 0, right? So this is Cj minus Zj, right? So this is minimization, right? So for minimization, what we need, all Cj minus Zj values should be greater than or equal to 0. So all Cj minus Zj values are not greater than or equal to 0, hence iterate. So hence we'll have to iterate. So here we have the where we have to identify the key column. So key column is the maximum, so positive value with the maximum value with a negative sign, right? So this is minus 4 is that particular case, will be our key column. And for key row we require ratio value, right? So ratio value will be there, and here ratio will be what? 1 divided by 1 will be 1, and it will be 6 divided by 4, it will be 3 by 2. So here also if you see, the minimum value is here 1 only, right? And that particular value will be considered for your, this value will be considered for identification of the key row, and this happens to be your key row, right? So now let's reconstruct our table. CB, CJ, here we have basic variables, right? We have basic variables. Then x1, x2, s1, s2, and no, particularly we also have a1, right? And here we have solution. Here we have x1, x2, s1, s2, and here it is a1, 1, 0, 0, 0, 0. We here have a solution, right? So here artificial variable will remain, it is not to be deleted. So here the entering the living variable was our s1, so instead of that I got x2. Here it is a1, x2 coefficient is 0, a1 coefficient is 1. So key now new values of key row will be 2 the old value divided by the key element. So 2 divided by 1 is 2, 1 divided by 1 is 1, 1 divided by 1 is 1, 0, x1, x2, s1, 2, yeah, 2, 1, 1, 0, and 0. And again, here will be 1 only, right? Nextly, we have new values to be found out for non-key row, and for non-key row, the value here will be, for the first value will be 1 minus 4 into 2 divided by, yeah, it will be 1 minus 2 into 4 divided by 1, and the value will be the value, if you check out, the value will be -7, right? Similarly, if we go on calculating the values, so here it will be 0, so you can take it up as a task, and you can check whether the values that I have derived are right or wrong, right? So here the value will be 2. Similarly, the Zj value I can calculate, Cj minus Zj value I can calculate. So here it will be -7, here it will be 0, here it will be -4, -1, -4, and here it will be 2, right? So Cj minus Zj, 0 minus -7 is 7, 0 plus 0 is 0, 0 minus -4 is 4, 0 minus -1 is 1, 1 minus -4 is 5, right? So here all Cj minus Zj values are greater than or equal to 0, right? So hence we can stop here. But now what has happened that the value of W, the value that we were targeting is now greater than 0. That is W is greater than 0, and your artificial variable is amongst your basic variable. So at least one artificial variable is amongst your basic variable, and a1 is in basic variables. So that is our case 1, and hence there is no feasible solution for given linear problem. So this happens to be your what? This happens to be your case 1, and it is to be solved in this particular manner.